Right. So advanced math class 2 is the last part. We're going to study probabilities. Okay. We have already spent time on counting, and that is a requirement for probability problems. Okay. Well, first of all, let's record probability. By definition, let me, I'll put uplet here. This probability of an event, in general we call event, okay, is defined by the ratio. Okay, the numerator is the number of design outcomes. The denominator is the number of all possible outcomes. Okay. An event is about counting the points in the geometry figure, for example, such like interval discus. In that case, the number will be replaced by like a length, area, volume, okay, according to the content of the event. Okay. But most of the problems we're going to study here today count the numbers. Okay, just to count the numbers. Okay, so the numerator usually we impose some conditions, so the number is smaller usually than the number in the denominator. Okay, so the probability is always is a number, is a value between 0 and 1. Okay, so let's take a look at the first problem. So a bag contains 6 marbles. These 6 marbles numbered 1, 2, 3, all the way to 6. Right? A marble is removed from the bag and without replacement. Okay. That means without replacing it. Then the second marble is drawn. So what is the probability that both numbers are the numbers? Okay. So okay, so there was a restriction on that. Okay, both numbers must be other numbers. So when you draw 2 numbers, okay, right, when you draw 2 numbers one by one, right, if without a restriction, okay, we have to figure out how many possible outcomes. Okay. So the number of all possible outcomes right, in order to get 2 marbles one by one, right, that's a 2-stage. Okay, step 1 and step 2. With 6 marbles here, right, 1, 2, 3, 4, 6. Where's my 5? Sorry. Sorry, this is I need to. Okay. So yeah, be careful. So you're going to draw 2 marbles one by one from a group of 6. Okay. So the first one, right? How many choices is there? That's 6 choices, right? Step 1. And the step 2, there are only 5 marbles left. There are 5 choices. Okay. The total number of the sequence of 2 numbers, okay, is going to be 6 times 5. Okay, because this just we're just trying to figure out how many possible outcomes, right? It involves 2 steps, the 3 independent steps, right? Step 1, step 2. Step 1, if there are 6 choices. Step 2, there are only 5 choices. The total numbers of ways to select those 2 numbers and putting them in a row is going to be the product of those 2 numbers in each step. Okay. Now, if you want to consider only other numbers, okay, then you can only select. Oh, I don't know what's going on with my phone. Okay, let me double check. It disappeared. Right. Sorry for that. So the number of design outcomes is you want to only get, you just want to get only other numbers, right? For other numbers, there are only 3 other numbers there. So you, right? So that's a restriction. You only can select other numbers. Step 1, there are 3 other numbers there. So you only have 3 choices. Step 2, only 2 other numbers left. So there'll be 2 choices. So the total number of ways to select the 2 other numbers, okay, and put in a row is going to be 3 times 2. Okay, so the probability will be the ratio of these 2 numbers. Okay, yes, the probability is going to be 3 times 2 and 6 times 5. It's 1 over 5. Okay. Now, if we modify this problem a little bit, like I said, first number must be odd, the second number must be even, and then it's still same idea. Okay, I just give an example. For example, yeah, what is the probability that the first number is odd, the second number is even? Okay, then you select an odd number first, which is 3 choices. Then also you select an even number, second step, right? It'll be 3 choices too. So it'll be 3 times 3. Okay, it's a slight difference. Right? But if you know the principle of counting, and you can always solve the problem. Okay, sometimes you ask it to find the probability that both numbers when it's odd, when's even. Well, that's a little bit more complicated, right? When's odd, when's even. Okay, that do not, that cannot be same odd number or same even number. So what is probability? Okay. So then probably double. Okay, so let's move on to the next problem. 2 distinct fractions are chosen randomly from the set. So this set has there 4 fractions there. What is the probability that sum is less than 1? Now, 2 distinct fractions are randomly chosen. So if you consider the sum, that means the order doesn't matter. All right? Yeah. You can also assume there's order here, first number, second number, okay? And because they're distinct, so that means when you select a number, there was no replacement, select the 2 numbers. Okay. So I think we're not going to count the order. Okay. You have the 2 numbers. You're going to choose A and B. Okay. That means no order. Okay. And that's going to be, the numbers of pair of the numbers, right? So the number of all possible outcomes is going to be the number of pairs of numbers, right? Select from this group of 4. So if you select a pair of numbers from a group of 4 numbers, the number choice is 4 factorial, 2 factorial, 4 minus 2 factorial. And after simplifying, that'll be 6. Right? But you can also do that 1 by 1. Yeah, but I will use a formula here. Okay, I can explain to you, without formula, you can also get the same number. So the question is the number of design outcomes. Okay, or can say design pairs. Okay, so we want to find out what pair of the numbers, when added together, the sum is going to be less than 1. So you begin with a 1/3. 1/3 plus 1/5, right, is less than 1 or not, right? Yes. Then 1/3 plus 7 over 10 is not. 1/3 plus 5 over 6, no. Okay. Then you look at 1/5. 1/5 plus 7 of 10. Yes, this is a larger than less than 1. Okay, all you have to do is just double, right? 2 over 10. 2 plus 7 is 9. Okay, and that's it. And the 7 tens plus 5, 7 of 10 plus 5 of 6. This is clearly is larger than 1. So you only have those two pairs of numbers. Since the order, we don't count the order, right? And clearly, the probability is going to be 2, that's 2 pairs, and over 6. Okay, the answer is 1/6. Okay. Now, yeah, how to count a pair of the numbers selected from a group of 4 numbers? Well, you can first of all, if you count the order, right? You select these 4 numbers, 1, 2, right? And put in a row. If the order is counted, then there will be 4 times 3. Okay. But when you switch it, you still get the same pair of numbers. So you have to divide by 2 factorial. Okay. So that's why you get 6. That's another way to get number 6. Okay. Right? According to the principle of counting, right? If you want to complete this procedure, involves several steps. Each step there's a number of choices. Okay, then the numbers of ways to complete this procedure with the product of those numbers you get from each step. Okay. All right, our next problem is a bag contains 5 red marbles, 7 green marbles. David draws out 2 marbles at the same time. What is the probability that they're both red? Okay, I wish you can work out this problem. If you get the answers, and please post it to me. Okay. All right, thank you, Joyce. All right, so you have we have 5 red marbles, right? 5 red marbles, and the 7 green marbles, 1 GG, right? Okay, 7. Okay, and we want to select, because draw out 2 marbles at the same time. That means we don't count the order, right? So they are a pair of numbers. So the number of pairs of marbles, right? That's the total number of possible outcomes, right? It's going to be 12 marbles total, right? You select 2, so 12 minus 2 factorial here. That's the standard formula. And then you simplify it. So that's a 12 factorial, 2 factors 2, and 10 factorial. So 12 factorial is 10 factorial times 11 times 12 is 2 times 10 factorial, so 10 factorial is gone. And that will be, 11 times 6, so 66. Right, that's the numerator. That's the denominator. Now you want to get red marbles only, the pair of red marbles, then you only select marbles from the group of red marbles. And there are 5 red marbles there, right? So 5 factorial, 2 factorial, 5 minus 2 factorial. Okay. Then you simplify it, and you will get 4 times 5, that's 2. I think it's 10. Yeah. You can quickly compute. So you got the numerator and denominator. The probability is 10 over 66. After you simplify, that's going to be 5 over 33. Okay. So we can do that. Yeah, this is the correct answer. 5 over 33. Okay. Similarly, you can do the following problem. Right. Here's a Christian has 5 different pairs of earrings. What is the probability that 2 randomly selected earrings will be a matching pair? So let's say I'm going to design 3 earrings. This is the one pair, right? 5 different pairs, right? You know, it's I saw some earrings looks like that, or just circle at 1 pair, right? We already have 4 pairs, right? And maybe like a music, like this type, right? Okay, so you have 5 pairs, but that's separate. Total, you have 10 earrings here, and you randomly pick up 2 earrings. Does not mean they match. Okay, so you have to. So what is the probability you get the match? So you grab 2 earrings, but think about the order doesn't matter, right? So if you select, yeah, remember, right? N factorial over k factorial times n minus k factorial. This is actually the number of a group of k members, right? And this k members selected from group of n members. N members. That's why we're using the formula here right now. Okay. All right. So you randomly pick up 2 earrings. Maybe that looks like that. Okay, but that's not a matching pair. Right? So Joyce, do you have answers? You have to figure out the numerator and the denominator. Right? Yeah, your denominator is correct. Okay, so the number of pairs of earrings is going to be, right, 10 factorial over 2 factorial, 10 minus 2 factorial. Okay, so let's simplify. 10 factorial is 8 factorial, 9 times 10, 2, yeah, 8 factorial, so 8 factorial cancels out, and that is going to be 9 times 10 divided by 2, it's 45. Now, the number of desired outcomes means the number of the matching pairs of the matching pairs, right? There are only 5 matching pairs there. So it's 5. That's it. Okay. It's just a 5, so the probability is a 5 over 45. Number 9. Good. No, there isn't matching 5, just 5 pairs there. Right? All right, So that is a that is a probability 1/9. Right now we're going to look at prime numbers. Okay, we randomly select the 6 prime numbers without a replacement from the first 19 prime numbers. Now, a 19 prime number, that's a very challenging problem. How can we list all of them? What is the probability that some of the selected numbers are? Express your answer as a common fraction in lowest terms. Okay, I know a few of them, so let's list a few, right? Yeah, in the 13, maybe it's 14, 15, 17, right? 19, and so on. So, yeah, it's not easy to get 19 prime numbers, but that's okay. So we can figure it out. Yeah, I think the difficult part is still the numerator, right? Like the denominator, let's do the denominator. So the number of pairs of prime numbers, right? It can be, total is 19 by 2 factorial, by 6, sorry, we're going to have 6 another, yeah, 6 prime numbers. I saw this pair of them, and 6, let me erase this. Yeah. 6 prime numbers, that will be 6 factorial, 19 minus 6, right? Right? So you simplify it, and that will be 19 factorial, right? So yeah, 19 is 13 factorial, 14, 15, 16, 17, 18, oh my God, 19. And this is 6 factorial and the 13 factorial. 13 factorial is gone, but 6 factorial. But it's pretty large number. Okay. Maybe I just want to keep the original one, okay, before I simplify. Let's keep it. Okay. Don't simplify it until we put them in the fraction. So the number of design outcomes, yeah, that's it. We want to make sure this pair of the primes, the sum is going to be up. Okay, think about it. That's my hint. Okay, I give you a half minute to pick it up. All right, so the number of design comes. So we want to make sure the sum is odd. The only way you can make it odd is the one of them must be 2. Okay, so 2 plus odd line numbers. Actually, we have 5 odd prime numbers, and it's going to be odd, right? So one of them is 2. So the first, so 2 2 is already fixed. All you have to do is just select 5 primes, 5 other primes from a group of 18, right? So it's 18 divided by 5 factorial, and that's 13 factorial. 18 minus 5 is 13. Then you see the reason I'm not going to multiply them out. So here's 18 factorial, 5 factorial, 13 factorial. That's 19 factorial. That's also 13 factorial. So now you can simplify, right? And turn this upside down. And you will see that 13 factorial immediately it's 19 factorial. 13 factorial is cancelled out. 6 factorial over 5 factorial is going to be 6. 18 factorial over 6, 19 factorial is 19. So 6 over 19. Okay, right? So 6 over 19. That's the probability. Right? Yeah, the sum of the six other prime numbers, if they're all of them odd, then the sum must be even, right? So one of them must be even, which is there's only one even prime number. All right, our next problem. There are equal numbers of pennies, nickels, dimes, quarters in the bank. What is the probability that the combined value of the 4 coins randomly selected with a replacement will be 41 cents? Right. So you're going there are enough coins of each type. Okay, just so many, maybe if we put in kind of a cylinder, just so many here, right? Right. Equal number, maybe 1 billion pennies, 1 billion nickels, 1 billion dimes, 1 billion quarters. Okay. So you randomly pick up 4 coins. Okay. Right. Yeah. What is the probability that the combined value of 4 coins randomly selected was a replacement? That means after you select 1 coin and put it back and select another coin. Right. And maybe you can always select a penny. Okay. But you want to get a combined value, which is 41. Now, how to get 41? At least you have to think about, right? You find out if you get all different coins, sum is right. So if all of the coins are different, then you get a sum of 41. Otherwise, you're not able to get 41. Right? Right? So, what is the number of all possible outcomes? So every time you write down, right? You write down the number you're going to get, right? Each time you select a coin and put it back. So every time you write down the number, right? Right. There's 4 coins there, right? Sorry, there's 4 coins here. So you think about because here was a replacement, right? Was a replacement. So that means there are 4 coins there. Each time when you select 1 coin, then you still put it back. So there are 4 coins. Just assume there's 4 coins there. You select, right? You select the coin 4 times. You can even select coin 5 times, right? So the first step 1, yeah, step 1, you have 4 different coins there. So there's 4 choices. Step 2, you put the coin back. So you also have 4 choices. Total is 4 to the 4th power. Okay. Right? 4 to the 4th power of outcomes. I could have a penny. It can be 1, 1, maybe 5, 5. That's a 1 no change, right? And that could be 1, 5, 25, and 10, right? Okay. So the first coin you get can be any of those 4 numbers. That can be any of those 4 numbers. Right? So the number of outcomes will be the product of those 4 numbers. Okay. Right, 1155, 1525, 10, for example. So you have a total, have a, it could be, it's possible, 1, 5, 5, 1. Those are 2 different. Okay, they're different. Right? Yes, all this counted here. All right. So total have 4 to the 4th power there. Then the number of design parts, right? You can only have only when you get 4 different coins, then you can get 41. But those 4 different coins can be in the different positions. So it's 4 factorial, right? You permutate 1, 5, 10, 25. So this is 4 factorial. This is the total number of outcomes. So you couldn't have 1, 5, 10, 25. You can have a 5, 10, 1, 25, right? So that's why 4 factorial meant. Then probability is 4 factorial of 4 to the 4th power, which is going to be 3 factorial times 4. And you simplify a little bit, 3 factorial is 6, then you have 4 cubed. Okay, 6 over, right, 3 factorial 6, 6 over 4 cubed. All right, and you multiply this out, you will get 32 and 3. 3 over 32. 3 over 32 is correct answer. Got it? All right, our next problem is randomly choosing 2 numbers from the set 1, 3, 5, 7, 9 with replacement. That means you can use any of these digits as many times as you want. You can pick up. So what is the probability that the product is greater than 44? How many numbers are you going to pick up? You're going to pick up 2 numbers. The order color? No, I don't think so. Just say choose 2 numbers. Choose a pair of numbers. All right. But question is, how do you? This was a replacement, so it's not like I choose a pair of objects. Okay. So we're not going to think that way. What we can do is, we write down 2 numbers. Okay. We write down 2 numbers, but you only use one of those 5 digits. number of possible outcomes, right? The first number you're going to write down. How many choices there? 5 choices. The second number you're going to write down also 5 choices because you know you select a number with a replacement, then you still put it back. There's still 5 numbers there. So that's why it's fine. Okay. Now you have to count those numbers. Right? Their product is greater than 44. But the order is counted, remember, okay? 44. So you begin, yeah, 1, 2, 3, 5, 7, 9, right? So 1 times any numbers, no. 3 times any number is still less than 44. So you begin with a 5. 5 times 7 is not. 5 times 9, yes. Right? So 5 times 9 is, okay. And it's also 9 times 5. And 7. 7 times 7. Yeah, be careful. It's also bigger than 4. 7 times 9. 9 times 7. Okay. Then 10 times 20. So the probability will be and 25. And then you have count 1, 2, 3, 4, 5, 6. So 6 over 25. This sounds. All right. The key point. Yeah, we just need to know how do we count, right? So sometimes you have to decide whether you're going to count the order, whether or consider the order, or sometimes it doesn't matter. Actually, you get the same result. If you grab 2 marbles, for example, right? You can grab 1 by 1. You can grab 2 without the order. But whatever, most of the time the probability is independent of the order. Okay, you should get same result. It doesn't matter how do you take 2 marbles out of from the bag. Okay. All right, so here's another problem. The digit D is randomly selected from the set from 0 to 9. What is the probability that the number 8,404 is divisible by 4? Okay, so I think you needed to first of all the number of design outcomes is easy, just 10, right? Right, the number of design outcomes is 10, and that's trivial. Number of all possible outcomes. This can be 10 because there are 10 digits you can choose. It's one step. Now, I want to see which digit D, right, makes the number 400, right? 4,800, 4,800, 8,400 D10, 4 is divisible by 4. Okay, let's take a look at this. And clearly, this is divisible by 4, this is divisible by 4, right? So the number is divisible by 4 if only 10 times D is divisible by 4. Okay. right? So it's this is a divisible by 4, right? 8,400 divided by 4, 4 divided by 4, right? So it's divisible by 4, 10 times d is divisible by 4. And the 4 is 2 squared, right? So 10 is multiple 2. So if and only if d is divisible by 2, I think. That's it. Okay. So d could be, right? Could be the 0, could be 2, could be 4, could be 6, could be 8. So total 5 choices. So the probability is 5 over 10 is 1. Right? Yeah, you sum of 3 numbers divided by 4, and 2 of them divided by 4 already. So the third one must be divided by 4. But 10d divided by 4 if only d is divided by 2, because 10 is already is a number. And then you see how many choices for the d. Okay. All right, so number 9. Number 9, yeah, you need to solve an equation. Okay. Yeah. Number 9, you have to solve equation. You don't know how many marbles there. It's different from the previous problems. Okay. Let's use R to denote the number of red marbles, okay, and W, the number of white marbles. We want to find out W and R. Okay, and based on the information. Okay, can you write down 2 equations in terms of R? All right, so we have to get some equations, right? The first, based off the first one statement, right? Choosing a random marbles, the probability is 3/5. So let's count to the probability, right? The denominator, okay, is the number of design outcomes. So you choose one marble from this bag. How many marbles there? R plus W. So this the denominator. You have R plus W choices. But for the numerator, you can only select marble, red marble. So there are red marbles there. That's this. So that is a probability to get red marbles. If you select only one marble from the bag, that should be equal to 3/5. So that's the first equation. Now, if you select two marbles, one by one, right? How do you calculate the probability? Well, two marbles, denominator, right? You select two marbles one by one, it's you put them in the order. So the first marble, you have a R plus W choices. For the second marble, you have a R plus W minus 1 choices because that was without a replacement. For the same reason, for the numerator, you want to only count red marble, right? How many possible ways to get the red marble? First of all, the first marble is red. That's R choices. Then you have to select another red marble, it's R minus 1. Now, the probability is 3/10. Now, are we able to solve this equation? There's two equations for R and W. The answer is yes. And you can select this one here. This is R over R plus W is already 3/5. Right? So after you simplify it, you will get R minus 1, R plus W minus 1, which is going to be 5/10 and number 2. Right? So you have two equations. That's the first equation, the second equation. Then you try to solve it. Okay? So the first equation, by the first equation, let's get cross product, right? 5R and equals 3R plus W equals 3R, 3W. That implies, and the 2R equals 3W. So that's the relationship. And the equation 2, I will get 2R minus 1 equals R plus W minus 1. Then you simplify a little bit, right? What do you get? R plus W minus 1, right? In the right example. Yeah, R plus W minus. Right? So let's simplify it. So you get 2R minus 2 equals R plus W minus 1. That implies R equals W plus 1. Okay? So now you have a very two simple equation. And so you can solve for W. Okay? And this two equation. Okay? You can replace R by W plus 1. So W plus 1 and 3W. That implies 2W plus 2 equals 3W. That implies W equals 2. Okay, once you get W equals 2, that's R equals 3. So you have a 2, 3. Okay, that's it. So you find the number of the marbles in the bag. Total only 5. Total only 5 marbles. Okay. R plus W will be, it's only 2 white marbles, 3 red marbles. Okay. So let's move on to next problem. If a positive 2-digit integer with distinct digits is randomly selected. So right now you only consider 2-digit integers with distinct digits. What is the probability that the number is multiple of 5 or divisible by 5? All right, so you have a 2-digit number. A is not equal to B. So let's count the number of all such 2-digit numbers, right? All 2-digit integers with distinct digits, right? So this is the number of all possible outcomes. You only consider those integers, okay? Then how to get that, right? First of all, there's only, just write down 2-digit integers, okay? Right? For the 10th digit, you have 9 choices. Then the unit digit cannot be the 10th digit. So you already use the 1 digit, so only 9 digits left. And that's why it's 9. So there are 81 2-digit integers with distinct digits. My question is, among them, how many of them are multiple of 5? That's the question. The number of multiples, okay? The number of the integers, such integer, okay? Because the digits should be different. Divisible by 5. It's going to be how do you count it? Okay. Yeah, please work on this. Okay. So how do we count them? Well, first, you know, a number is divisible by 5 if and only if I think A, B, right? First of all, A cannot be equal to B. Then B can be 0 or 5. So there's only 2 choices there. Okay. So then you will get A 0, right? And here A cannot be 0, or A 5. A cannot be 5, but A cannot be 0, right? All right. How many choices there? The total is 9, first group. The second group, it's only 8, so 17 choices. So the probability is 17 over 81. Right, 17 over 81. Right? You know, you divide them into 2 groups. You have to make sure the digits are different. Okay? One end, the unit digits is 0, otherwise the unit digit is 5. Okay? And the first digit anyway cannot be 0. Then it cannot be 5 in the second group. That's why there's only 8 choices. So it's 7. Yeah, just be careful, you know, right? Choice. It's a 17 over 81. All right. The very last problem we're going to discuss. The very last problem we're going to discuss. Okay, 8 students sitting in a row. 8 students sitting in a row. Okay, that's left and right. 4 students sit on the left side, 4 other 4 sitting in the right hand. And among them are David and John. David and John is there. So what is the probability that if David wishes to sit next with John on the same side? So that means you randomly put 8 students in a row. What is the probability that John and David is on the same side? That's it, right? Doesn't matter, you know, which side and who is on the left, who is on the right. As long as there could be, this could be David, you know, right? This could be John. They're not necessarily be next to each other. They just want to sit on the same side. Okay. So step 1, right? The number of all possible we here call the arrangement. Okay, it's going to be you have 8 seats, 8 students, so you can permutate them. Total will be 8 factorial, right? Choices. Now the challenging part is how do I make sure David and John sit on the same side, right? Yeah, how do we guarantee it? David and John on the same side. Anyone has answers? 3 minutes left. All right, let me figure out how to make an arrangement. So I guarantee David and John on the same side. Step 1, I let David select a seat. Okay, doesn't matter which side. So there are 8 choices. Okay, then John selects a seat on the same side, right? As David. Otherwise, there will sit different, right? Then 1 seat is already occupied by David, so 3 seats left. There's 3 choices. Then third step, assign seats to other 6 students. Yeah, other 6 students. And you have 6 seats left, 6 students left, randomly permutate them. So there are 6 factorial. So the number of the design outcomes, design arrangement, right, is going to be 8 times 3 times factorial. Then you simplify. Then you simplify, the probability is going to be 8 times 3 times 6 factorial, and this is the top one is 6 factorial. Then you simplify, right? Then you simplify 6 factorial, and 8 times 6, 6 factorial times 3, and that will be 8 factorial is a 6 factorial times 7 times 8. So 6 factorial is gone, 8 is gone, so 3/7. Not too bad. So 3/7, that is a probability. If you randomly assign 6 to 8 students, David and John will be, sit on the same side. Okay, so we will continue one more lesson to study probability. Then we are done with this advanced 2, okay, advanced math class 2.